Good morning, everyone. Myself, Anil Karthik, and my teammate Kishore Kumar. We have made a circuit for simulating a hydraulic valve through a button or a switch. So this is a schematic of our circuit. So let's see. Let's go with this. So this is a constant block, and then it is connected to an ideal angular velocity source, and then this is connected to a fixed displacement motor. So as we have to actuate a hydraulic valve, so we need flow. So I have added this fixed displacement motor, and then there is a tank. So the fluid which is contained in the tank will be pumped through the motor through a pipe, and after the pipe there is a solenoid valve, and then after the solenoid valve there is the main tank. So to actuate the solenoid valve, we actually need a physical signal. So what we have done is we have taken a manual switch which is connected to two options, that is constant block 1 and constant block 2, which has a value of 0, 1, 0 and 1. 0 means the switch is in off condition, 1 means the switch is in on condition. So as a send electrical signal, so we have attached a Simulink PS converter which will convert the electrical signal to a physical signal which is required to actuate the solenoid valve. So this is a circuit of our project. So then we'll run the program, and as we see there's SimScape results. We need to click onto that, and then it's loading Visuals Explorer. It will take a while. Yeah, the window has opened. So this is the panel. So the left side of this panel, it has all the components which we have used in the circuit. So as we want to see the flow through a valve, which is a solenoid valve, I'll take these two graphs, which is m dot A and m dot B. M dot A is the mass flow rate, RTA, that is the inlet of the valve, and m dot B is the mass flow rate at the outlet of the valve. So now the circuit is in off condition. So um, we'll see the m dot A value. The m dot A value is a curve, and then after a small rise, it just saturates. So, and it's in the range of 10 to the power minus 6, which is the range of 15 to the power minus 6, I think so. So, and before this, I have to show you this. That is, we have a leakage area of 1E minus 10. So, um, so So as we see, there is a raise. So now, generally, if the switch is in off condition, there should be no flow. So if we set that leakage area as 0, we'll see a very horizontal line at the value 0. But the thing is, we cannot give the leakage area as 0 in MATLAB. So it is given 10 to the power minus 10. So and this curve is in the range of 15 to the power minus 6, which is very minimal. So which is nearly represent there is no flow. And then let's see about m dot b. So in the outlet, the flow will be negative, and the curve decreases from 0 and then saturates at the negative minus 15 10 to the power minus 6. And this still says that there is no flow at the outlet. Now we have to double click on the manual switch. Now let's turn to the on condition. We'll run the program, and then we go to some skip results. It's open, and if we see the solenoid valve, now we'll see the m dot a of the on condition of the button. So m dot a, there is a slight raise in the positive side that is above 0. So this shows that the flow is linear, and then there is no turbulence. So we have got a very horizontal linear line, and then and flow in the inlet will be positive. And then when we go for m dot b, the line shifts to the negative portion of the graph, and then it is linear too because there is no turbulence in the fluid. So it is horizontal. And as said before, the flow at the outlet is negative. Uh, and then with these two graphs, we can say that the circuit is used to actuate a valve through a manual switch. And then, thank you.